So step 3 of the hypothesis test is where your big work is going to come from. We are going to determine the sampling distribution that you're going to choose and then calculate the test statistic and the p-value. And fortunately for you, everything is done on the graphing calculator. So I just want to walk you through these steps. Just like back in chapter 7, you have 3 options. We are talking about proportions, which is the p, and if that's the case, there will either be a percent or a part out of the whole, and that tells you you're going to use one prop z. There's no choices, done. If your problem has a mu, or the mean, then you get to choose whether it's z or t, and it's the same rule again as confidence intervals. If you know the sigma, you choose the z. If you don't know the sigma, then you choose the t. Remember that if sigma is known, you will have 3 words: population, standard, deviation, if they don't give you the symbol. If sigma is not known, they might tell you S equals, or they'll use the word standard deviation, but without the word population. So the first thing you have to do is decide which of those 3 tests you're going to use, and then it's just a matter of typing in all the information that's given from your problem. Now, one of the things you're going to be asked to find is the p-value. And this is the strategy that we're teaching you. I mentioned that chapter 8 has different strategies. We're teaching you the p-value strategy. The basic idea is that the farther out in the tails of the distribution that the test statistic value is, the more we want to reject the null hypothesis. The p-value is just a way of telling how far out in the tail the test statistic value is. The p-value is one more way of finding probability, specifically of getting a test statistic at least as extreme as the one representing the sample data, assuming that the null hypothesis is true. The null hypothesis is rejected if the p-value is very small, and so we're going to compare p-value to the alpha, which we'll talk more about in a minute. The p-value will be found using the hypothesis test functions on the graphing calculators as shown on the next few slides. So you don't have to calculate it, but you do have to be able to interpret it. The p-value is another concept that if we had more time, we could go into more definitions. For our purposes, we really just need for you to evaluate the p-value, even if you don't quite understand what it is. The test statistic is the other thing that you're going to be asked to find. While we won't be specifically needing the test statistic while we're using the p-value method, it is an important part of some of the other methods, and it will be asked for in some of your assignments. So, a test statistic is found by converting the sample statistics, such as a p-hat or an x-bar, to a standardized score, such as a z-score or a t-score, with the assumption that the null hypothesis is true. Again, this could be done using a formula, but we will be using the hypothesis test functions on the graph calculator as shown in the next few slides, and the test statistic will either be a z equals or a t equals depending on which test we use. So here are some screenshots that you may want to look back at as you're doing your homework. There will also be some great examples for you to watch later, but we like for you to see it all. We've already talked about most of this. We use the one prop z when you're dealing with a proportion or percent. We use the z-test when we have the mean and sigma is known. We use the t-test when we have the mean and sigma is not known, or the s is known. Here are the instructions for how to do the keystrokes. You're going to be shown this in the videos for the examples, so I'm not going to read this right now, but you're welcome to pause and read it if you want to. I did want to point a few things out on this slide. I know there's lots of screenshots, it's a little overwhelming, but it does show you the 3 different types of tests and how you can walk your way through an example. So at the top, you'll see that we're going to press the Stat button and then arrow over right to Tests. The p-test, or the one prop, is number 5. The z-test is number 1. And the t-test is number 2. Those are the only 3 tests we're using. And then the most important thing I think for you to remember is that instead of using H for hypothesis, they go ahead and use the variable they're talking about. So when it asks for P sub 0, you're going to write the same number that you used in your H sub 0 hypothesis. Same thing for the z-test. It'll say mu sub 0. You're typing in the number from the H. And in the t-test, mu sub 0, you're typing in the number from the H. So the very first number you type in is the number from your hypothesis. Then you'll fill in the other information. And then at the very bottom, you'll highlight the sign from your alternative. So you can see there's the not equal to that comes first, then the less than, then the greater than. Sometimes people have trouble deciding which symbol is which. I tell people ignore the letters and just look at the symbols. Less than is pointing to the left, greater than is pointing to the right. And then you have a choice because the bottom of the screen says calculate or draw. So we've given you those two screenshots. The third box down is the calculate box. And you'll see this again in the examples when you watch the videos. When you hit calculate, all you see is data. And the test statistic will be the second number down, z equals or t equals. And the p-value will be the third number down, which is the p. I prefer the draw. So instead of hitting calculate, you hit draw. It will show you the normal curve. Sometimes it's shaded, sometimes it isn't. But the only information it gives you are the two pieces that you need. The z-score test statistic will be on the left-hand side underneath the normal curve, and the p-value will be on the right-hand side underneath the normal curve. If you use the calculate, it does give you some things that you won't need, and so that can be a little distracting. But it does give you what you do need, and so it will be up to you to decide whether you want to calculate or to draw. Again, this is a great slide to look back at if you get confused in any of your homework problems, to look back at what it should be. The last thing that you need for step 3 is to identify the significance level, and we've already made reference to this. The significance level is the Greek letter alpha. It's for a hypothesis test is the probability value used as the cutoff for determining when the sample evidence constitutes significant evidence. So the significance level is based on significant evidence against the null hypothesis. Remember, a hypothesis test is testing whether something is true or not. So the alpha is basically how much evidence do you have against your null. By its nature, the significance level alpha is the probability of mistakenly rejecting the null hypothesis when it's true. Thus, we want it to be small if your results are to be trusted. It's possible to make mistakes, we know that, but we want the probability of your making a mistake to be small. And so the rejection or critical region has an area equal to the significance level and is the set of all values of the test statistic that cause us to reject the null hypothesis. This is the area of the tails identified back in step 2. It's separated from the rest of the graph by the critical values, z-scores and t-scores. And again, if we were teaching you the critical region method, this significance level would be used in a different way. The way we're going to use it is in comparison with the p-value. And so common choices are going to be 0.05, 0.01, and 0.1, similar to the alpha we saw in chapter 7 that was always split between the two tails. This time we know it could be just the left tail or just the right tail. In chapter 8, alpha can be the area in one tail or split. And here's the most important part about alpha. The value of alpha will always be given in the homework problems so that everyone's answers are consistent. If you were doing this as a statistician, you could choose how low you wanted your alpha to be, but it will be given to you. Now the trick is, you got to remember that the alpha is the same as the words significance level. And so that will be important for you to get in your head.